Hey guys, this is part 3 problem solving video lesson on relation and function. So in this video you'll have some more problems with their solution, so stay with me. Which of the following function is a one-to-one correspondence? Okay, ከነዚህ ከተሰጡት ፋንክሽኖች ውስጥ one-to-one correspondence የሆነው የትኛው function ነው? Our function is a mapping from real number to real number. So real number in order real number map የሚያደርግ ከነዚህ ከተሰጡት ውስጥ one-to-one correspondence የትኛው ነው የሚለው ጥያቄው። So f is one-to-one correspondence. F is one-to-one correspondence if it is both one-to-one, if it is both one-to-one and onto. Okay, this condition must be satisfied. Then we say that f is one-to-one. Then if these two conditions are satisfied, the function is a one-to-one correspondence. So let us see the choice in A. In A we have f of x is equals to absolute value of x. So is it a one-to-one correspondence? Let's check for a one-to-oneness. So for this function we can take f of minus 2 and f of 2 are the same. Both of them absolute value of minus 2 and absolute value of 2 are the same, which is 2. But minus 2 and 2 are different. Two different first entries are mapped with the same second entries. So minus 2 comma 2 and 2 comma 2 are an element of f. So this is not one-to-one. It's not one-to-one. So A cannot be the choice. So let's see the B case. In B, f of x is equals to x squared. So similarly, f of minus 2 is 4, which is again the same as f of 2. So two different first entries are mapped with the same second entries. Minus 2 comma 4 and 2 comma 4 are an element of f. So two different first entries are mapped with the same second entries. So this function f is not one-to-one. So it will not be a one-to-one correspondence. Let's check for the function in C. In C we do have f of x is equals to this function is the greatest integer function. So let's take some number for this. F of 2.5 is 2. Similarly, f of 2.9 is also 2. So still we can have two different first entries are mapped with the same second entries. So f is not one-to-one. This function is not one-to-one. So you can show using more general ways. Let's check for D. In D, the function f of x is x. Okay, so let's check whether this is a one-to-one correspondence. So using the definition of a one-to-one condition, f of x1 is equals to f of x2 implies x1 and x2 are the same. So this function f is one-to-one. Okay, so let's check the second condition. Is it an onto? So we need to check whether this is an onto function or not. Since the range of f is real number, which is exactly the same as the second set, this implies f is onto. Okay, f is onto. So by definition, the function f is onto if the range of the function and the second set are the same. Therefore, this function f of x is equals to x is a one-to-one correspondence. It is both one-to-one and onto, so we call it a one-to-one correspondence. So our answer for this question will be D. Which one of the following is true about the function f of x is equals to x squared times sin m of x? So what is given? The function f of x is equals to x squared times sin m of x is given. Okay, so we can rewrite this as x squared for x greater than 0, and it becomes 0 for x is equals to 0, and minus x squared for x negative, right? So we can write this like x squared 0 minus x squared. This is the given function, ይሄ ነው functionaችን, because by definition sin m of x is defined as 1 for x positive, 0 for x is equals to 0, and minus 1 for x negative. So በx ስኩዌር ስናባዛ የምናገኘው ይሄንን ይሆናል ማለት ነው። So which of the following statement is true about the given function? In A, the domain is a set of all real number. So the function can take any real number, therefore the domain is all real number. So obviously the answer is A. So we need to check the rest of the choices are false. For example, let's check for the B case. F is not an even function, or f of x and f of minus x are not the same. This is different. So f is not even function. You can take f of 2. F of 2 is 2 square, which is 4, but f of minus 2 is minus of 2 square, which is minus 4. Therefore f is not even. B will not be the answer. If the function is not even, it will not be symmetric with respect to the y-axis. Okay, it's not an even function. Only even functions are symmetric with respect to the y-axis, therefore it's not symmetric with respect to the y-axis. And the range is y greater than or equals to 0. That is also wrong. The range is all real number. The range of this function is all real number. So the answer for this question will be A. Which one of the following is neither even nor odd? Okay, ከነዚህ ውስጥ ኢቨንም ኦድም ያልሆነው የትኛው ነው ነው ጥያቄው። So let's check each of them separately. In A, f of x is equals to absolute value of x. Obviously f of x and f of minus x are the same, which means absolute value of x and absolute value of minus x are the same. So f is even. Okay, so this is even function. We are searching neither even nor odd. So let's check for B. In B, f of x is equals to x squared. Still we can see that f of x and f of minus x are the same, which means x squared and minus of x squared are the same. So f is even. Okay, the function in B is also even. Let's check for the C case. In C we do have f of x is equals to x cubed plus x plus 4. Okay, let's check what f of minus x means. F of minus x means minus x cubed plus of minus x plus 4, which is the same as minus x cubed minus x plus 4. So f of x and f of minus x are different. F is not even. Let's check whether it is odd or not. So if we take the negative of this, let's take the negative of this, negative of x cubed plus x minus 4, which is different from the negative of f of x. So f of minus x is different from minus of f of x. So f is not odd. Okay, the function in C is neither even nor odd. It will not satisfy the definition of an even and odd function. So this is neither even nor odd. We can see that the synonym of a function, okay, the synonym of a function f of x is equals to synonym of x. Let's check what this looks like. Synonym of minus x and minus of synonym of x are the same for any x an element of real number. Okay, so this function is odd, so the only answer is C. C is neither even nor odd. One of the following is a one-to-one correspondence function. So let us check each of these functions separately. The function f is a mapping from real number to real number. In A, we have a function mapping from real number to real number defined by f of x is equals to the power of x. So we are going to check two things. F should be one-to-one and onto. So now let's check whether f is a one-to-one or not. F of x1 is equals to f of x2 implies 2 to the power of x1 is equals to 2 to the power of x2. This gives us x1 and x2 are the same. So f is one-to-one. So we need to check one more thing for this function. Is this function onto the range? So we need to check the range. The range of f is, or all the possible values of y will be y greater than 0, right? So the range of the function f is different from the second set R, real number. So this is not an onto function. This is not an onto function. Therefore, f is not a one-to-one correspondence. Let's check for the second function, the function in B. In B we have the function in B is a mapping from real number to positive real number including 0 defined by f of x is equals to x squared. So here we can see that f of minus 2 and f of 2 are the same, which is 4. So two different first entries are mapped with the same second entries. This implies f is not one-to-one, so B will not be the choice. Let's see the C case. In C we have f a mapping from real number to real number defined by f of x is equals to x plus 1. Okay, here let's check the two conditions. F of x1 is equals to f of x2 implies x1 plus 1 is equals to x2 plus 1, which gives us x1 and x2 are the same. So f is 1 to 1. This function is 1 to 1. So we need to check one more thing. We need to see the range of f and the second set are the same. Therefore, the range of f is real number, which is exactly the same as the second set. So f is onto. You see, this function satisfies both the condition of 1 to 1 and onto. Therefore f is a 1 to 1 correspondence, okay. So C can be the answer. It is a 1 to 1 correspondence. Why D is not the answer? For example, if we see the function in D, f is a mapping from real number to positive real number defined by f of x is equals to absolute value of x. Here you can see that f of minus 2 and f of 2 are the same, or f of minus x and f of x are the same. Okay, so f is not 1 to 1. Let f of 3x minus 2 is x squared minus 4, then which of the following is not true? Okay, let us write the given information. Okay, given that f of 3x minus 2 is x squared minus 4. Okay, so the composition of a function f with 3x minus 2 is quadratic, which is x squared minus 4. So here we can make things clear. Let the inner function, this 3x minus 2 is g of x. Okay, g of x is 3x minus 2, and the composition of f and g is x squared minus 4. So we don't know f. So our f should be quadratic. F of x should be quadratic, ax squared plus bx plus c, because the composition of linear with quadratic will give us quadratic in the given order. So we have to determine the unknown function f. So here we need to determine the unknown function f first. So f of g of x, or f of 3x minus 2 means, according to this, it becomes a into 3x minus 2 the whole square plus b into 3x minus 2 plus c. So this composition gives us x squared minus 4. So this implies squaring 3x minus 2, you will get 9x squared minus 12x plus 4 plus b into 3x minus 2 plus c is equals to x squared minus 4. Okay, distributing a, b here, you will get 9ax squared minus 12ax plus 4a plus 3bx minus 2b plus c is equals to x squared minus 4x means x squared plus 0x minus 4, because here we are going to compare two quadratic. So this can be written as 9ax squared plus minus 12a plus 3b by collecting like terms. These are like terms containing x, plus the rest are constant. 4a minus 2b plus c is the same as x squared plus 0x minus 4. Okay, So by comparison, 9a should be the same as the coefficient here. Okay, 9a should be the same as 1, and the coefficient of x here, minus 12a plus 3b is equals to 0, and the constant term for a, minus 2b plus c is equals to minus 4. So here we can get a will be here, dividing both sides by 9. By 9, a will be 1 over 9. So substitute here a, so the b value becomes 4 over 9. And substitute a and b here, you will get the c value, which is minus 32 over 9. Okay, therefore the unknown function f of x becomes x squared plus 4x minus 32 over 9, because in all the a, b, c we have over 9. So this is our function f. So which of the following is not true? B is a true statement regarding the function f. Let us check the rest. F of 10. F of 10 means 10 squared plus 4 times 10 minus 32 over 9. You can get that this is 108 over 9. The result is 12. So still B is also true. Let's check for C case. In C, f of 1. F of 1 means 1 squared plus 4 times 1 minus 32 over 9. The result is minus 27 over 9, which is minus 3. So still this is true. So the only option will be D. You can see that in D, f of 2 will not be 0, or f of 2 will be minus 20 over 9. Okay, you can check. Let R is a relation defined by this. Then which one of the following is not true? So if we want to find the inverse, there are different techniques. Here, if we keep x and y as it is, we have to interchange the place of x and y. So x becomes ay plus b. This implies y becomes x minus b over a. So this is a true statement regarding R inverse. So if you interchange x and y, you have to keep y is equals to x plus b as it is. Therefore this is also a true statement. Again, b and c are the same because this is also an inverse. Y is equals to ax plus b implies y minus b over a will be x. So b and c are the same statement. So the only option will be D. So here in D, we don't have R inverse. This R inverse is not really the inverse of the given relation. ምንድነው እዚህ ጋር የምናደርገው here ይሄንን ለx solve አድርጎት ነው ያስቀመጠው. Okay, this is R itself, not R inverse. Okay, let f of x is minus 1 plus sin m of x. Then which of the following is not true? The given function is, okay, the function is f of x is equals to minus 1 plus sin m of x. Okay, this can be written as minus 1 plus 1 for x greater than 0, because sin m of x is 1 for x positive, and minus 1 plus 0 for x 0, minus 1 plus minus 1 for x negative number. So this can be written as, 0 for x greater than 0. It becomes minus 1 for x is equals to 0, and it becomes minus 2 for x less than 0. So this function can be expressed as f of x is equals to minus 1 plus sine m of x can be expressed as 0 for x positive. It becomes minus 1 for x is equals to 0, and it becomes minus 2 for x less than 0. Now let's see which of the choice is wrong. F of x becomes minus 1 for x is equals to 0. Okay, for x is equals to 0, the function becomes minus 1, therefore it is true. And f of x is equals to, the function becomes 0 for x greater than 0, still the choice in B is also true. And the function becomes minus 2 for x less than 0. For x less than 0, it's minus 2, therefore this is also true. So the only wrong statement about this function is the choice in D. For x greater than 0, it will not be 1, it becomes 0. The inverse of the function is, okay, what is asked here? The inverse of y is equals to 1 minus 2x over 1 plus x. So to find the inverse, we interchange x and y first. So interchanging x and y, we get x is equals to 1 minus 2y over 1 plus y. So we solve for y. So this becomes x times 1 plus y is equals to 1 minus 2y. So this implies x plus xy is equals to 1 minus 2y. Rearranging the terms, we get x times y plus 2y is equals to 1 minus x. Factoring y, we get x plus 2 into 1 minus x. Okay, now you can divide both sides by x plus 2 by x plus 2. The result becomes y is equals to 1 minus x over x plus 2. So this will be the inverse of the given function here. Therefore, our answer will be A. Let f of x is x minus x squared and g of x is 1 over x. Then g of f of 1 over x is equal to what? Okay, let us substitute everything as the given information. F of x is x minus x squared. So f of 1 over x will be 1 over x minus 1 over x squared, which is the same as 1 over x minus 1 over x squared. So this can be written as x minus 1 over x squared. Or you can use crisscross and simplify. So this is f of 1 over x. So f of 1 over x becomes x minus 1 over x squared. Now we substitute f of 1 over x in g. G of x is 1 over x. So this implies g of f of 1 over x, g of f of 1 over x, which means g of x minus 1 over x squared. Okay, this becomes 1 over x minus 1 over x squared. The result is x squared over x minus 1. Therefore, the answer for this will be B. Let f of x is 3x plus 1 over x minus 2. Then what is the range of f? So here we need to be very technical. The question is the range of f or the domain of the domain of f inverse. Okay, we know that the range of f and the domain of its inverse are the same. So the easy way is to find the inverse of the function. Our function is f of x is equals to 3x plus 1 over x minus 2, or y is equals to 3x plus 1 over x minus 2. Now find the inverse of this function. So when we find the inverse, we interchange the place of x and y. 3y plus 1 over y minus 2. So this means x times y minus 2 is equals to 3y plus 1. Okay, distributing x times y minus 2x is equals to 3y plus 1. Collect the y's together. xy minus 3y is equals to 2x plus 1. So factoring for y, x minus 3 is equals to 2x plus 1. Now dividing both sides by x minus 3 by x minus 3, you will get y, or which is f inverse, is equals to 2x plus 1 over x minus 3. So the domain of f inverse is, now domain of f inverse is all real number except 3, which will be the range of f. Okay, the range of f and the domain of f inverse are the same, therefore the range of f will be all real number except 3. If f of x is ax minus b and f inverse of x plus 1 is half of x plus 2, for each x an element of real number, what must be the value of a and b? Okay, so here what is given that f of x is ax minus b and f inverse of x plus 1 is half of x plus 2. So this implies f of half of x plus 2 will be x plus 1. Okay, now we substitute this half of x plus 1 in f, and the result is x plus 1. So f of half of x plus 2 means a into half of x plus 2 minus b, which will be x plus 1. Okay, we substitute half of x plus 2 in the function f, the result is x plus 1, which is given here. Okay, so this means a over 2x plus 2a minus b is equals to x plus 1. Now by comparing the two linear, the coefficient of x here is 1, the coefficient of x here is a over 2, so a over 2 should be 1. At the same time, 2a minus b is a constant term, and the constant term on the right side of the linear is 1, so 2a minus b should be 1. So a over 2 is 1 means a is 2, and we substitute 2 here. 4 minus b becomes 1 whenever b is 3. Therefore a is 2 and b is 3, which is the required answer. If f of x is square root of x cubed and f of g of x is 4th root of x, then what is the value of g of 8? So what is given here, f of x is given, which is a square root of x cubed, or we can write this like x to the power of 3 over 2, and g of x is given by, f of g of x is given by 4th root of x, or you can rewrite this thing like x to the power of 1 over 4. Now the question is g of 8. So calculating g of 8 requires knowing g of x. So f is a power function. The composition of f with g is a power function. Therefore, the unknown function g is also a power function. So let g of x is a certain power function, say x to the power of r. So if this is our g of x, now we use the given information. F of g of x means we substitute g in f. So substitute g in f. So it becomes x to the power of r, the power of 3 over 2. The result becomes x to the power of 1 over 4. So from here we can see that x to the power of 3r over 2 becomes x to the power of 1 over 4. This implies 3r over 2 is equals to 1 over 4. Crisscross it, 12r becomes 2. This implies dividing both sides by 12. By 12, r becomes 12 over 2 over 12 or 1 over 6. So our g of x becomes x to the power of 1 over 6. Now we can calculate g of any number. G of 8 becomes 8 to the power of 1 over 6. 8 means 2 to the power of 3. 2 to the power of 3, the power of 1 over 6 means 2 to the power of 3 over 6. The result is 2 to the power of 1 over 2. 2 to the power of 1 over 2 means radical 2. Therefore, g of 8 becomes radical 2. If f of x is radical x plus 2 over x plus 2 and g of x is 1 over x minus 2, then f of g of x is the required question. So f of g of x means we substitute g in f. We substitute g, which is 1 over x minus 2, in f. So substitute this thing in place of x, substitute 1 over x minus 2. So 1 over x minus 2 plus 2 over 1 over x minus 2 plus 2. This means radical 1 over x over 1 over x, because minus 2 with 2 becomes 0. So this means x times radical 1 over x. So we can write like this: square root of 1 is 1, 1 over root x. The result is x over root x. But we don't have x over root x, so we have to rationalize it. Rationalizing this will give us x root x over x. So this becomes a square root of x. So the more simplified form of f of g of x will be square root of x. So our answer will be C. If f of x is ln of x over x minus 1 plus 2 for x greater than 1, then which one of the following is the inverse of the given function f here? So it's given that f of x or y is equals to ln of x over x minus 1 plus 2. So to find the inverse, interchange the place of x and y. So x becomes ln of y over y minus 2 plus, y minus 1 plus 2. So this can be written as taking both sides by logarithm, or this can be written as x is equals to logarithm of y over y minus 1 plus 2 in base e. So this means e the power of x is equals to y over y minus 1 plus 2. So this implies e the power of x minus 2 is equals to y over y minus 1. So crisscross it and solve for y. So y minus 1 times e the power of x minus 2 is equals to y. This means y times e the power of x minus 2y minus e the power of x plus 2 is equals to y. So collect all the y's together. So y times e the power of x minus 3y is equals to e the power of x minus 2. We take this to the right and collect y's together. So this means y into e the power of x minus 3 is equals to e the power of x minus 2. Now divide both sides by the e the power of minus a, e the power of x minus 3, e the power of x minus 3. Now the y value, or y can be expressed as e the power of x minus 2 over e the power of x minus 3, which will be the inverse of the given function. Therefore, the answer for this problem, or the inverse of f, is in A. If f of x is this one, then f inverse is, so what is given here, f of x or y is given by 1 over e the power of x plus 1. Then we are asked the inverse, so we interchange x and y first. Okay, so we solve for y. X times e the power of y plus 1 is equals to 1. Okay, so this means x times e the power of y plus x is equals to 1, which implies x times e the power of y is equals to 1 minus x. So dividing both sides by x, e the power of y becomes 1 minus x over x. So now we take both sides by logarithm of base e, e the power of y is equals to logarithm of base e 1 minus x over x. Okay, so this implies y is equals to ln of 1 minus x over x. So this is the inverse. Okay, the f inverse becomes ln of 1 minus x minus ln of x. Okay, using the properties of logarithm, we can write the inverse of the given function in this form. So the answer becomes A.